Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 27, 2025, about 9 days ago. This paper introduces Micro-Rotated-GPTQ, a format-specialized post-training quantization method that delivers up to 3.6 times layer-wise and 2.2 times end-to-end on NVIDIA B200, and up to 6 times layer-wise and 4 times end-to-end on RTX 5090. The paper is titled Bridging the Gap Between Promise and Performance for Microscaling FP4 Quantization. And as we will see later, the accuracy and speed gains arrive with negligible overhead. In short, the study shows why standard methods fail on MXFP4 and NVFP4, then uses rotations and format-aware scaling to recover accuracy, bringing MXFP4 within about 1-2% of NVFP4 and roughly 98-99% of FP16 on large models. Also, the authors shared the official FP-Quant repo. You'll find the main model quant.py script, a SRC folder with quantization, transforms, and utils, plus assets, and an inference library. It includes single GPU quantization, MXFP4 and NVFP4 export with QuTLASS kernels, HF and VLLM integration, example inference snippets, and evaluation scripts. Alright, the repo overview was done. Figure 1 shows that a Hadamard rotation makes weights and activations look normal, which means the values cluster smoothly without heavy tails. A Hadamard rotation is an orthogonal remix that spreads energy across dimensions, so no single element dominates. The native unrotated distributions fit a Laplace shape with outliers, which amplifies quantization error in FP4. This normalization explains why micro-rotation stabilizes scaling and reduces top element error. While Figure 2 shows that Hadamard rotation hurts at small group size and helps as group size grows, because relative mean squared error, which scales error by the value size, falls once outliers are spread across the group. MXFP4 remains worse since its power of 2 scale is coarse. By contrast, NVFP4 preserves top values and stays stable. Figure 3 on the right confirms that the E4M3 scale range comfortably covers observed weights and activations. So Table 2 reports recoveries measured with real kernels across models and methods. NVFP4 leads on accuracy, often reaching about 99% on Qwen-3. MXFP4 trails, yet Micro-Rotated-GPTQ lifts it into the mid-90s on several models. Hadamard transform helps the group size 32 format like MXFP4. With round to nearest, it harms NVFP4 because its group size is 16. Quantization-aware training adds only small benefits. So Table 1 compares W4A4 accuracy on Llama 3.18b instruct across formats and methods. NVFP4 leads on average, with recovery around 96% when paired with smooth quant or GPTQ, which aligns with the small seed variance. INT4 comes close, but shows higher variability. MXFP4 lags, yet Micro-Rotated-GPTQ lifts it to about 93% recovery. Hadamard rotation helps the group size 32 format and hurts the group size 16 format. So Table 1 set the rankings. Figure 4 shows the same pattern under real kernels, highlighting how the Hadamard transform changes recovery. The overall chart reports average recovery, where NVFP4 stays highest and MXFP4 improves when rotations are used. On the left, the round to nearest group shows that adding the Hadamard transform hurts NVFP4 but helps MXFP4. In the middle, GPTQ remains strong, with a small boost for MXFP4. On the right, quantization-aware training adds limited gains, again larger for MXFP4. Alright, Figure 6 shows that the kernels deliver near-ideal efficiency because the overhead from rotations and scaling stays small. The left panel tracks single-layer throughput versus batch size, and the actual curves closely follow the ideal lines. On B200, layer-wise speedups reach about 3.6 times, while on RTX 5090, they reach about 6 times. The right panel reports end-to-end gains in versus LLM, rising with batch size. On B200, overall speedup reaches about 2.2 times. So the big picture is clear. FP4 is not an automatic upgrade over int4 because format quirks break standard post-training quantization. Micro-Rotated-GPTQ solves that with rotation and format-aware scaling, restoring accuracy, while QuTLASS delivers 2 to 4 times end-to-end speedups. Thanks for listening. I am Alex, and this was the AI Research Roundup.